So congestion in network may occur when the load on the network is greater than the capacity of the network. Retransmission policy. Here, the packets can be retransmitted if it is lost or corrupt. Data cannot transfer to destination. It is obviously yes. So once the congestion is at router number 3, from here after data is cannot transfer. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the unit Data Link Layer. So in this session, let us discuss about the concept of congestion. Let us see what is a congestion here in a network. So congestion is an important issue that can arise in a packet switcher network. So in a computer network, so a congestion can arise. So what is a congestion? Congestion is a situation in communication network in which too many packets are present in a part of a subnet or performance and the performance degrades. So what is the definition of a congestion here? Congestion is a situation in network which too many packets are present in a part of the subnet. And what is the drawback of this? Because of congestion, the performance of the network degrades or has come down. So congestion is nothing but the heavy traffic in a computer network. Suppose a data packets are moving across a network from one router to another router or from one to multiple network devices. So while during the transmission, there are chances of network congestion because of so many issues. So because of congestion, the performance of the network comes down. So there are chances of data loss, delay in the data communication, or the delay in a packets or data reaching the destination, or it may lose, or it may lost, or it may damage. So there are various causes or various problems with the help of network congestion. So congestion in network may occur when the load on the network is greater than the capacity of the network. So in general, every network has its own capacity or is a limitation. So data has to be transferred within that particular limitation. Suppose if it crosses the limitation, then obviously there is a chance of congestion. So what is the definition of congestion here? So any network or any data transmission or any data packets are moving across a network beyond the capacity of the router, that is a situation is called congestion. So network congestion occurs in case of traffic overloading. So in another way, we can say it is a traffic overloading. If there is a heavy traffic across the network, the chances of delay in data communication or transfer of data from one device to another device or from host to destination. So this one you can simulate with in our day-to-day life. In general, traffic jam in particular area or particular street. So why there is a traffic jam in many of the areas or in the roads in a city? The simple reason is that the capacity of the particular road is there is a limit for each and every road, so that the vehicles or different types of vehicles can be crossing over it. But if it exceeds the capacity or the limit of it, then obviously there is a chance of traffic jam. So in that case, the traffic jam has to be released, it has to be taken care of. So you can simulate that example even in the case of network congestion here, almost similar to that. In the next slide, now once the congestion arises, then next we have to control the congestion. How it is possible to control the congestion? So congestion control refers to technique and mechanism that can either prevent congestion before it happens or remove congestion or after it has happened. So there are three possible conditions for any network congestion. So similarly, if you simulate this with our day-to-day life network jam or traffic jam in our day-to-day life, in our city or in any of the road. So here, if at all if there is any traffic in a road, obviously a particular person or the traffic police, they have to come, they have to regulate the traffic, or they have to release the traffic, or they have to clear the traffic. So in that way, if you compare that, or if you take an example with the network congestion with respect to computer network, here there are three possible conditions. One, we can prevent the congestion. There is a mechanism or a technique before it happens, or remove the congestion after it has happened. There are two possibilities. One is we have to control the congestion before it occurs or before it happens. That is the one thing. Or once the congestion arises or occurs, it has to be cleared. So there are two possibilities that can be controlled. So congestion control mechanism are divided into two categories. One is prevents the congestion from happening. This is one stage, or it is one mechanism, and another category is removes congestion after it has taken place. Now the types of congestion control are, one is open loop and closed loop. These are the two categories of controlling congestion in a computer network. Now look at the example for open loop congestion control. So in this method, the policies are used to prevent the congestion before it happens. So open loop, we have to prevent the congestion to happen. That is in open loop. So congestion control is handled either by the source or by the destination. So here, this open loop, it is going to avoid the congestion to happen, or to avoid the congestion to take place, and it can be handled either by source or the destination. And there are various methods used for open loop congestion control. One is retransmission policy. Here, the packets can be retransmitted if it is lost or corrupt. So one of the possibilities is that any data packets which are lost across the network, it can be retransmitted. This is one of the method. Next one is window policy. So here it uses selective reject window method. And acknowledgement policy. So here sending acknowledgement to the sender. See, these are all the various methods used in open loop for congestion control. Now let us see what are there in a closed loop congestion. So it is a control mechanism, try to remove the congestion after it happens. So in open loop congestion, so it is going to control the congestion before it takes place or before it occurs. But in closed loop, so congestion is removed or is going to clear the congestion or to remove the congestion after it happens, after it rises. Now, there are various methods used for closed loop congestion. They are, one is for back pressure, choke packets, implicit signaling, and explicit signaling. These are the four methods. So congestion can be controlled in closed loop. Now let us see what is back pressure. Assume that in the network, so here S is a source, and between we have 1, 2, 3, and this is destination. So here in between source and destination, we have different network devices or nodes. So here this is upstream and downstream. So what is back pressure? Here data can transfer to the destination. So this is first point. Data is going to transmit from source to destination. See, this is the arrow mark indicates that data is transmitting from source to destination. Next point is the data packet written to the previous router if congestion arises. So now assume that, so this is the congestion at the router 3. Suppose if there is a congestion at the router 3, so obviously data packets cannot reach the destination. In that case, so the data packet written to the previous router. So the data packets already reached the router 3, it will be moved back to the previous router is 3. All the packets from here moves to router 3, and from 2 it moves to the back to the router number 1 and to the source. So this is the meaning of data written to the previous router. Finally it reached the source. Then it slowed down the data transfer. Once the data packets which could not reach the destination, which are returned to the source, then the source computer at this stage, the source node is going to slow down the data transfer in the network. So this is a back pressure, one method of controlling the congestion. Next one is choke packet. So this is another technology or another mechanism where congestion can be controlled. So here again, look at the same example here, source and destination here. In between we have multiple nodes. And suppose if we assume that congestion is at router 3. Take the same example here. Now, data cannot transfer to the destination. That is obvious, that is true. Means once the congestion is at the router number 3 and no data can transmit after the router 3 across the network. So obviously it will not reach the destination. Next, the router will not send packets to the upstream. So here it is downstream and this is called upstream. From here is called upstream. So as we have seen in the previous example, if there are any congestion here, the data packets move back to the previous router. But in this example, in choke packet mechanism or technique, so here data packets sent to the upstream and will not send to the upstream, and router sends special packet to the source directly. So instead of sending the data packet to the previous router, this router sends a special packet called choke packet to the source. Then after the choke packet reach the source node here, so that then the source computer or the source node slow down the data transfer. So this is another method of a choke packet technique or mechanism to control the network congestion. In the next slide, we will see what is implicit signaling. Another method of congestion is implicit signaling. Let us take the same example, source, destination with multiple nodes in a network. Now here, data cannot transfer the destination. If at all, if there is a congestion at the router 3, data cannot transfer to the destination. That is true. So if the sender does not receive any acknowledgement from the destination, it senses or gets the congestion in the network. So actually this implicit signaling works with the concept of acknowledgement here. So what is this? So as and when the data packets reach the destination is going to send the acknowledgement for each and every packet which has been sent from the source node. So actually, suppose the source does not receive any acknowledgement from the destination, then it assumes that, or it senses or guesses that there may be a congestion in the network, then obviously is going to slow down the data transfer. So this is implicit signaling. So if the source computer or the source node does not receive any acknowledgement from the destination, then it assumes that, or it senses that there may be a congestion, and automatically it's going to slow down this data transmission to the destination. So this is implicit signaling. In the next slide, we will see explicit signaling. So what is the explicit signaling? Now let us take the same example here, source and destination here. So data is moving from source to destination through multiple routers. So here data cannot transfer to destination. It is obviously yes. So once the congestion is at router number 3, from here after data cannot transfer. So the concerned router send a signal to the source or destination. So here the concerned router, for example, so congestion is at router 3. So this particular router, it sends the signal. It sends the signal either to the source or to the destination. So the signal can send in forward or in backward direction. So to slow down the transmission rate or slow down in the sending the acknowledgement. So this is forward direction and backward direction. So here, if at all any congestion at router 3, it sends a signal to either in forward or to the destination, or backward means to the source. By analyzing the signal, so here the source, it is going to slow down the data transmission rate, or they can have a concept of acknowledgement. I mean, till the acknowledgement is received from the destination, the source, it cannot transfer the next set of packets to the destination. So this is the concept of explicit signaling. Students, in this session, we have discussed about the concept of congestion. So what is congestion? So that is with respect to computer network congestion, so that the data packets from the source cannot reach the destination because of various technical reasons. So, and also we have discussed about the different congestion control mechanism or congestion control techniques. So let us continue our discussion in my next class. Thank you very much.